Welcome to Dynamic Coaching Center. So this is Dynamic CAD, a unit of Dynamic Coaching Center. So in this video, we'll be seeing about the ANSYS software and the course content of that, and basically how far this ANSYS software has been used in the field of computer-aided engineering. Everything will be explained in detail. And this particular presentation will also cover what are all the different syllabus by which we are actually trying to train the students and make them professional to work in the field of computer-aided engineering. So let's get started. So first we will be seeing about what is design validation, then what are all the different methods to validate any design, then what is meant by analytical method, what is numerical method, what is experimental method, then how many number of numerical methods are there, and what is finite element method, which you might have done in your BTech or BE, then what is boundary element method, then finite volume method, then finite difference method, then what is the difference between computer-aided engineering and computer-aided design. Okay. So all these factors we'll try to cover, and at the end of this video, we'll also see about the detailed syllabus of our professional ANSYS program. So design validation means we have to check whether the component which we are going to manufacture will actually sustain the various loading conditions or not. The loading conditions means it could be a force or torque or pressure or whatever may be the different kind of things based upon what type of analysis you are doing. In other words, we can say design validation is a process to find out the results like stresses, displacement, strain, fatigue life, eigenvalues, heat flux, depending upon what type of analysis you are doing, by which the model may or may not actually lead to failure. Okay, so this is what the main motto of design validation. So basically you have three departments like CAD, CAM, and CAE, right? Computer-aided engineering. So this computer-aided engineering is a one where we try to validate the design process. Okay, computer-aided design is a one where the model will be done. So this is basically a modeling thing where under the CAD software you will get the SolidWorks, for example, Creo, CATIA, NXCAD, AutoCAD. Let's say, for example, you are actually trying to model a rod which you are seeing in the screen right now. Okay, so this can be done in any of these softwares like SolidWorks, Creo, CATIA, NXCAD, and AutoCAD, right? And you have to save this model in the format of IGES or STEP, because these are the two universal graphic standard by which any software can operate. So if you can actually model this particular cylindrical rod and save that file in the IGES or STEP format, not in the .prt format, part file format, because that will open on the particular software alone. This particular model, after getting saved, can be exported to computer-aided engineering, where in the computer-aided engineering, you have softwares like ANSYS, Hypermesh, ANSA, Abacus, and many more, right? Where you will try to validate the design. Now I'll come to the point of validating the design. Let's say that this cylindrical rod which we have modeled is being subjected to a loading condition, let's say axial tensile load, okay, as you can see from the figure. Now this you might have done in your laboratory doing your BTech study, where there will be a neck formation, and this neck formation will try to reduce the cross-sectional area, and at one point of time when this load actually reaches a maximum level, this necking area will keep on increasing and decreasing the cross section, and then suddenly it breaks down, right? And this exactly looks like a cup and cone fracture, provided this is a ductile material. Let's assume that it is a ductile material. So cup and cone fracture takes place. Now we'll check for what type of load, under what magnitude of load is actually causing this failure. Okay, now as per the application of the client, if that particular load is being applied and if the component is not getting failed, then this person from the computer-aided engineering will give the information to the computer-aided manufacturing, where the manufacturing or production will start. Suppose if we take that when we try to actually validate this rod, and if we end up with a failure, then what suggestion will computer-aided engineering engineer will do is he will actually direct this CAD person to undergo some modification in the dimension, and that dimensional change will be determined by the computer-aided engineering field engineers, okay, where he might increase the diameter or decrease the length depending upon the application, okay. So, and once again, when the model is been done and again saved in these two format, it will be once again sent back to the computer and engineering field, where the engineers will try to again try to validate the design by applying the tensile load. And now if it sustains, then again he will give the information to computer aided manufacturing to start the production. So this is what the design validation means, okay. Now there are three methods to validate any design. One is analytical method, and next one is numerical method, and third one is experimental method. Now, for example, you might have been most familiar when you have read your strength of materials or mechanics of solids in your BTech study. You might have dealt with something called a simply supported beam, right? So let's assume that there is a point load which is acting exactly at the center of the beam. Let L be the total length of the beam, and this half is L by 2 and this half is L by 2. Now you know that because of this vertical transverse load, this beam is now going to bend or deflect. And this is a point where the maximum deflection occurs. Let me put the deflection as y. So the maximum deflection will be y suffix max, y max. And this particular deflection you might have derived using different methods, like double integration method is there. Double integration method is there. And then Macaulay's method is there. So using all these methods, you might have derived and found out some expression for this y max, right? Like for example, if I take P as the load, then it would be PL cube by 48 EA. Something like this, you might have end up with an expression where E stands for the Young's modulus. This is wholly a material property by which the beam is made up of. And I stands for the moment of inertia. And if you go for the cross section, suppose if this is of, let's say, a rectangular cross section of B and D, then your Ixx would be BD cubed by 12, right? Similarly, for circular, it would be pi by 64 D per 4. So these are all the different values based upon what type of cross section your beam is and what type of material your beam is. And P is the load by which it is acting on the center of the beam, and L is the length. Now, analytical solution is what which we are seeing here. And to find out the stress also, we'll be able to find out. See, for example, you might have been familiar with the bending equation, M by I equal to sigma by Y equal to E by R. So if you compare these two first terms, then you might have end up with sigma is equal to my by I, which is nothing but m by I by y. This can be rewritten like this. Now this I by y is called as z, which is called as section modulus, which actually determines the strength of the section. So which is nothing but now m by z. So this is what the stress expression. This stress is nothing but the bending stress, because you see that the beam is actually bending and it is subjected to bending stress. This bending stress should be within the allowable limit, so that if it sustains, then it will be sent for the production by the computer engineering field members. But if it is not so, then they will try to modify the cross section of the beams. Like in the case of suppose if it is made up of rectangular cross section, they might modify some B and D to give some stability. So this is what been done in the analytical method. So basically analytical method means it is a textbook method where you will try to integrate and find out an expression according to the methods which you have learned in your mechanics of solids or strength of materials. Okay, by using that expression, you can actually find out the answer. This is what the analytical method is. This gives you an exact expression and exact answer. Now coming to the experimental point of view, just now we have seen in the case of the cylindrical rod, where this would have been done in the universal tensile testing machine, UTM, in your laboratory, strength of materials laboratory, right? Where you might have subjected the rod to the tensile load and see at which point it is breaking, at which load correspondingly the rod gets failure. So based on that, you can actually note it down. Then there is one more method called numerical method, where you will use the computer as a hardware and software as something like ANSYS, ANSYS, Hypermesh, anything, and use that to validate the design and find out the same two parameters of deflection and stress. Now each method has got its own advantage and disadvantage. So for example, if you go for the analytical method, it gives 100% accurate results. And if you take the disadvantages of analytical method, it finds only the results if the formula is known, right? Which means you have to derive and keep your expressions ready. And it is a time consuming one, as you know that when you try to derive an expression for simply supported beam for the load acting at the center, it takes several pages, right? Some 2 to 3 pages. And accuracy can't be believed blindly because it depends upon the person who tries to derive that expression. And calculations can be done only on the single point. This point I'll explain you. See, for example, if you take the same example, the load is acting at the center, which means you are actually finding out the expression only for the load is acting at center point and correspondingly what is the maximum deflection. But you know that as the beam is deflecting, this is your maximum deflection, but here also there is deflection, here also there is deflection, here also there is deflection. But these are not at all taken into account while doing the derivation. We are focused on only at one point. So this is a major disadvantage. You can do the calculations on only one point. Then coming to the experimental method where you will experimentally determine, the advantage is physical and manufacturing errors can also be considered while calculating the results. And this also gives the actual measurements. But the disadvantage is it's a time consuming and needs an expensive setup. Say, for example, if a company is producing, let's take, for example, the same cylindrical rod expression. So if you are trying to manufacture this, each company will try to produce, let's assume that they are producing some nearly 10,000 parts. You can't actually randomly pick a few parts and try to put it in the UTM machine and try to check it out. So it is actually a time consuming one and needs an expensive setup, and applicable only if the physical prototype is available. Generally, they will check for at least 3 to 5 prototypes per lot. Let's say for each lot contains 100, they will randomly pick some 3 to 5 prototypes and try to check it out. So this is what the experimental procedure is. Now, if you go for the numerical thing, where we try to apply our ANSYS software and then try to evaluate the results. The advantages is we can solve the real-time complicated problems. Results can be achieved faster because of the use of computer and software. And results can be achieved on the entire geometry. Like for example, if you take this case, the contrary to this would be this point. So which means that for the same simply supported beam which is subjected to a point load at the center, you can find the deflection not only exactly at this point, which is the maximum deflection, you can even find out at this point, this point, this point, this point. Okay, so that is the main advantage. Then one more advantage is applicable even if the physical prototype is not available, which is contrary to this one. Disadvantages is it is an approximate result, but you can now advanced methodologies have been come together that we are going to apply those algorithms using which the software has been built up in such a way that these two will have nearly the same answer. It won't get varied that much. So now there are four numerical methods which are available. The one is finite element method, otherwise called as finite element analysis. The next one is boundary element method. The third one is finite volume method, and fourth one is finite difference method. So we'll see one by one. So finite element method, it is a numerical technique because it comes under the numerical method, and it is used for finding the approximate solution to the boundary value problems of the partial differential equations, because all the engineering relevant applications have been formulated as partial differential equation, and it is also referred to as finite element analysis. So there can be various inputs based upon the application or the component which you are analyzing. Let's say, for example, the loads could be of any type such as forces, pressure, velocity, acceleration, temperature. And then constraints will be applied generally on the body. Let's say, for example, if you have a cantilever beam, you know that this one end has been completely fixed, which means all the 6 degrees of freedom would have been arrested. Okay, so that is called constraint. Constraints will also be applied. And on the other end, suppose if you are applying a load, that would also be given as an input. Then on the output side, you will be mostly finding out the stresses, strains, deflections. Deflections will also fall under the same category of displacement as per the CIE software is considered, and you might also see some internal forces which are acting. Then input and output may also vary with respect to time depending upon what type of application you are analyzing. So this is a insight of giving you the normal component, and then that has been converted into meshed component, which means finite element means we'll be dividing into several elements which you can see here. Then finally, after applying all the inputs, necessary inputs like loads and constraints, you will end up with a solution which you can see in the animated version also. Next comes the boundary element method. It is often used as an engineering design aid, which is similar to finite element method. The only difference is that it is more and more towards the surfaces, whereas the previous one, finite element method, which falls under the numerical method, is actually applied for the entire body, whereas this is for surface. Inputs also looks in the similar fashion that there could be loads and supports and constraints. Loads might include force, pressure, velocity, and acceleration. And output also looks in the similar fashion as that of the finite element method, which is forces, stresses, strains, and displacements. Here also you can vary the inputs and outputs with respect to frequency. For example, you can consider this car body door, okay, which is a surface component. So where you will be employing the boundary element method, which also comes under the numerical method. So the next one is the computational fluid dynamics, which is a most important thing. It is actually a software based on finite volume method. Okay, so most of the finite volume where we consider unit volume operations will be taken care in case of thermodynamics and fluid problems. So unit volume is considered as per the finite volume method is considered. It is similar to finite element analysis. The only difference is there we'll consider as an element, here we'll consider as a volume. And variable properties at the nodes actually include here pressure, velocity, area, mass, etc. Instead of the forces which we consider in finite element method, here most of the input parameters will relate to pressure, velocity, area, mass, etc. And it is mostly based on the Navier-Stokes equation. And all these computational fluid dynamics will generally try to apply these principle of law of conservation of mass, law of conservation of momentum, and law of conservation of energy equilibrium equations. And inputs, as I previously said, that it might include velocity, pressure, mass flow rate, and temperature. And output would be same as like we might even consider the exit velocity, pressure, and temperature variations. And you might also look for some liquid mass and volume fractions and lift and drag coefficients. For example, you can take this example where a F1 Formula race car is actually going at a very high speed, and you know that there would be some aerodynamic cuts which would have been done in the entire part or the geometry of the F1 race car, because the flow of air in the opposite direction should surpass this without disturbing this entire body. This can be validated using computational fluid dynamics, which is a subpart of finite volume method. So there is one more method called finite difference method, where finite difference method and finite element method share many common things. Okay, so in general, I can say that finite difference method is described as a way to solve the differential equation, and it is used in combination with either boundary element method or finite volume method to solve the coupled problems. Coupled in the sense it would be a combination of thermal and CFD. So let's say, for example, we can take an airfoil structure where we are trying to find out our aim is to find out the stress. But initially we are being left out with the airflow mass flow rate, right? So you might know that regarding the airfoil structure, there would be a difference in pressure on the upper side and on the lower side, and there would be some air which is flowing through, which might carry some mass flow rate, which is in kg per second. For 1 second, how much kg of air is flowing? Okay, only this is the input which you are having. Then what you can do is you can first apply the finite volume method and then try to evaluate the pressure, and using that you will be able to find out the load. Then you can transfer this same problem to finite element method now. So first you are applying the finite volume method to find out the pressure, and from there you are finding out the load or force acting on the airfoil structure. Now using this you can import the same model to finite element method, where you will be able to find out the stresses, which is what the exact output which you are looking for. So in this way you can use the finite difference method as a coupled problems, like what we have seen for thermal and CFD coupled problems. Okay, so CAD is all about generation or creation of the 3D model. Whatever be the model given to you from the CAE engineer as per the dimension, the duty of the CAD designer is to just produce the same model or model it. Okay, so for example, if you are trying to analyze this bridge, then the CAD model engineer will actually try to give this model. Then this CAE engineer will actually convert this into a meshed model, where it will be divided into several number of small elements. Okay, then it will be subjected to the boundary conditions, which is the constraints and the loading part, and then it will be animated and found out for the output parameters like stresses and strains, and see whether it is within the allowable limit or not. If it is there, then they will go for the production. Okay, if it is not there, then definitely they will go for some modifications for the dimensional change for the CAD model engineers. Then they will redo this process. Now coming to our syllabus, as far as ANSYS is considered, this is a professional syllabus where we'll be dealing with several topics. Okay, it's not like the normal syllabus which has been followed in any of the design centers. So it will be quite different. So we'll be seeing about the theory of finite element method and computer-aided engineering. So what are the different ways to validate the design? Just now what we have seen, and all these topics would have been covered here. Then the next thing is we'll be seeing about the 1D components and how to do the 1D meshing techniques and how to do the geometry editing using the ANSYS software. So under this heading, you will cover all these topics. Okay. So creating a line geometry, editing the line geometry, creating the cross section, assigning the cross section, creating the truss structure and creating roll gauge structures. Okay. Now, then comes the 1D meshing part where we'll be dealing with some of the beam problems of cantilever type, fixed beam type, and simply supported, and also the truss structure. Then we'll also go for real-time applications where we'll give some 10 industrial projects for practice. The next one is the 2D components and how to do the geometry editing for the same. So creating the surfaces of the geometry from the line geometry, mid-surface extraction. So editing the 2D surface geometry and defeaturing the 2D surface if it is having some unnecessary features which will disturb the meshing part, then we have to remove that. That is called defeaturing. So converting the 1D line geometry into 2D surface geometry and importing and repairing the 2D meshing and creating 2D elements. What are all the different mesh options used in the ANSYS software? Then we'll also see a sample problem which has been related to your design of mission elements or mission design, which you might have studied as a subject in your engineering, where we'll be applying different meshing techniques to model and mesh a plate with the whole problem with and without washer, and what is a biasing technique which can be employed, and we'll also do some quality 2D element check for the meshing, and we'll also give some 10 industrial projects for practice. Then the next one is the 3D element creation and the geometry editing, where we'll be going for the importing and repairing of solid geometry, how to do that, and creating solid geometry will also be given in the ANSYS software itself, and how to do the editing of the 3D solid geometry, and what about the defeaturing things which has to be done in the 3D solid geometry. Then comes the 3D meshing techniques, where we'll be seeing about the tetra meshing, penta meshing, and how to do the editing part, and hexa and pyramid meshing, and how to do the editing part. Then 3D meshing using speed method, and then 3D meshing using the multi-zone command, and 3D meshing quality checks. Then 10 industrial projects will be given for this. Now comes the different types of analysis. So static structural analysis, where we'll be seeing about the basics of the static analysis, what is meant by static structural analysis. Then we'll be doing these activities, which is the Bajar roll gauge by applying the forces, and then we'll be analyzing a pressure tank by applying a pressure. Then we'll be analyzing a brake disc by applying the temperature. Then we'll also give some 5 industrial projects for practice. Then comes the transient structure analysis, where we'll be dealing again with the theory of transient analysis, and transient analysis on the bridge would be done, where the force location is changing with respect to time will be given as an input. For the same transient analysis on the bridge, we'll be seeing for the force location changing with respect to time and adding the effects of vibration. Then comes the transient analysis on the brake disc, which we have seen in the structural case. Now we'll subject it to the transient structural case, where the temperature and location are changing with respect to time. Then after doing this, we'll give some 5 industrial projects under the same analysis. Then comes the inertia relief analysis, where the theory of inertia relief will be discussed in detail. And here we'll actually try to work it on an industrial A arm by applying the forces at multiple locations. Then 5 industrial projects on inertia relief analysis will also be given. Then comes the eigenvalue buckling analysis. Then we'll discuss about what is buckling and what is the eigenvalue method which has been used for doing the buckling analysis. Where we'll be doing the eigenvalue buckling analysis on tall building structures, calculating the first buckling load factor. Then comes your axisymmetric analysis, where theory of axisymmetric analysis would be discussed in detail, and how to apply the same analysis on the industrial pressure valve. And under this topic, we'll give you another 5 industrial projects for practice. Then comes the modal analysis, where the modal analysis on Bajar roll gauge would be done by finding the natural frequencies and different mode shapes by which it is vibrating. Then 5 industrial projects would have been given for your practice. Then comes the steady state thermal analysis, where theory of steady state thermal and basics of your heat transfer would be discussed in detail. And the same steady state thermal analysis on brake disc by calculating the heat flux and temperature distribution would have been done, and 5 industrial projects would have been given for the practice. Then comes the transient thermal analysis, where now the temperature is changing with respect to time and location. We'll take the same brake disc and try to apply the same, and also we'll give 5 industrial projects for this analysis also. Next comes your explicit dynamic analysis, where theory of explicit dynamic will be discussed in detail, and we'll take the same Bajar roll gauge expression and we'll try to do the front impact crash analysis, and we'll also include some 5 industrial projects for practice. Then comes the CFD part. Theory of computational fluid dynamics will be discussed in detail. Then CFD internal flow analysis on a benchery, and then CFD external flow analysis on an airfoil structure. Then CFD mixed flow analysis on hydraulic mixture will also be done. Then comes your composite analysis, where theory of composites will be discussed in detail, and composite analysis and how to do it on a propeller shaft and airplane wing will be discussed, and 5 industrial projects would be given for the practice. Then comes the nonlinear analysis, where theory and types of nonlinearity would have been studied. Nonlinear and gap analysis will be discussed in detail. Nonlinear plastic deformation of the beam would have been discussed in detail, and 5 industrial projects for practice would have been given. Then comes the contact analysis. So theory and different types of contact, and what are all the structural analysis of the gear pair in contact. And now one more example is structural analysis using friction contact in clamps. Then 5 industrial projects will be included under this topic. Then comes the radiant power analysis, where theory of radiant power would be discussed in detail, where we would have included analysis of catalytic converter to find the radiant power. Then here also we might include some projects for practice. Next comes your CFD, theory of CFD, where CFD of 3D wind turbine blade analysis would have been discussed, and 3D vehicle to determine the drag and lift coefficients would be discussed, and 5 industrial projects would be given for the practice. Then comes topology optimization, where theory of topology optimization would be discussed in detail, how to optimize a component. And here we'll take one more time the A-arm, optimization of an A-arm by optimization of the brake disc. Then 5 industrial projects will be given for the practice. So these are all the different things which we cover under the ANSYS. And few of the insights and basics of finite element analysis we are planning to launch as the video in the YouTube for public, and 50% of this course would have been covered in Udemy. So those who can't offer for the entire course can actually visit our Udemy, where we have placed the courses in levels of 1, 2, 3 under both the topics of Tamil as well as in English, which can be availed. And you can purchase that and try to cover the 50% of the syllabus. For getting the 100% use of the entire essence of the syllabus, try to contact us. Okay, so just watch our videos in the YouTube, where we would have given in the description about the Udemy link and also the playlist link, and we would have also given our mail ID and phone number where you can contact and try to join the course. And we are actually providing 100% placements, okay, based on the freshers or those who have passed out in the recent years of within 3 to 4 years, we can actually try to make a good placement also. Okay, thank you.